Okay, so next question. The diagram shows a solid cylinder. The cylinder is made from titanium. The density of titanium is 4.43 grams per centimeter cube. Now, this is really important here. It says calculate the mass. Now, what's really important here is you've got to see here, it says the density. So density here is mass over volume. You see, they've done it here, look, mass over volume. So that's what they're saying here. It says the density is so much per centimetre cubes. So how many centimetre cubes do I have in there? Well, this is a cylinder. It's got a circle at the top. So that's pi r squared for the circle, times it by the height. And that gives you 3 dimensions. That's your volume. That's what your volume equals. So on my calculator, what I would do is I'd say, right, it's pi, shift pi, times the radius. Now, if the diameter is 8, the radius is 4, so it's 4 squared times 15. And I would write all this down on the sheet. Okay, you get method marks, so you write it all down. That equals 240 pi. Now I'm going to leave it as 240 pi. Okay, because then it saves me all trying to work out all the rounding up. That's how much volume there is, and it's for that's the total number of centimeter cubes. How many of these go in that? That will give me my mass, won't it? Because mass here, mass, if you look at this, mass is density times volume. So I would do that. Every 1 centimeter cube carries this amount of density. So I've got that lot of this. So there we go, boom, times by 4.43 equals, and now I'm going to put it into that form, 3,340 to 3 sig fig. They wanted to 3 sig fig. Joseph travelled from his home, so here his home is here, must be, to 15 kilometres, oh there we go, 15 kilometres away. He then stayed for a time, this is where he stays, didn't move, so that's stationary. And then he returns home, comes home. Now, that's steeper, so that's quicker, and that's slower. He meanders home, doesn't he? At what time did he leave his home? Well, look at this, 14:20, halfway, so it must be 14:10, 10 past 2. How far was Joseph at 10:30? Okay, so 10:30, let's go all the way up, and then across. You can see he was 10 kilometres from home. 10. How long did Joseph spend in his friend's house? Right, so he went from that point to that point there. So from 440 to 500, that's 20 minutes. That's how long he spent there. Okay, right, let's move over to this one. Wow, okay, well, we had a cumulative frequency curve in the last question. So, I don't know if they asked the second one, but it might ask Box Whisker this time. Find an estimate for the median salary. So 60 mathematicians, so therefore the median is going to be 30. So you go right across from 30, all the way down, and there's your median value because it's half the 60. Yeah? Right, and then it says, oh, I see where we're going to go with this one. It says the 60 minutes, they had a minimum salary of 1,600, maximum 48. Use this information and the cumulative frequency curve to draw a box plot. Box plot needs 5 things: minimum, maximum, median, lower quartile, and upper quartile. So I need to find the lower quartile and the upper quartile as well. So go back to this, and the median, which is the middle quartile, we said that came as 30,000, didn't we? So if that's 30, half that's 15, so that's your lower quartile there. We call that Q1, and that equals 25,000. And then our upper quartile is another 15 above the 30. Oh, look how nice that is. Look how nice that is. And that comes to 35,000, so Q3 is 35,000. That's kind of nice, isn't it? 25, 30. It's symmetrical, really nicely symmetrical. And you should see that here. So as we said, it was 25. Yeah, 25. So I'm going to go up to there, draw a line like that, 30 and 35. There's my box. It's nice and symmetrical. And then the minimum salary was 16, which is there. Put a line like that. And the maximum 48, which must be there. Put a line across like that. So that's my box and whisker. Okay. The university also surveyed 60 archaeological graduates. The box plot below shows this information. Now, okay, it's sort of in line. Oh, it's not, is it? Well, it is sort of in line. Yeah, if this was expanded bigger, it would be even better. Compare the distribution of salaries. Well, one thing you could say is, first of all, the median here is 30, whereas here it is 19,000. So on average, the median value for maths is higher at 30. So you could say that. The maximum salary here is 40, whereas this one is 48. Maximum minimums aren't the best ones to do. The range is useful, so the range is quite good. You can say this range goes from 16 to 48, so that's the 32,000, and you'd write it out, that's a range of 32. This is a range of 30, so the ranges are about the same. Okay, just this is shifted across higher salary. You can look at the interquartile range. You can say the lower quartile here is 25, whereas the lower quartile here is 15. The upper quartile is 25, and the upper quartile is 35. So actually, the upper quartile here, so the top 25% of people here earn the same as the top 75% here. So again, you've got all this you could talk about. Now, this one. A coach is designing a new football strip. He has a choice of 4 different pairs of socks, 3 different pairs of shorts, and 11 different shirts. Okay, how many different stripes are possible? Okay, let's just take it down. Let's say it's just socks and shorts. So 4 socks, A, B, C, D. And each of these could have 3 different shorts. So that could have shorts 1, 2, 3, 1, 2, 3, 1, 2. So basically 4 times 3. So that would be 4 times 3. That would be 12 different choices there. But each of one of these could have 11 different shirts. So it'd be 12 times 11, 132. Wow, different ones. Okay, and I think that's everything. Happy days.